Hello, Griffins. One more edition of Regents Chemistry video number 7. We're going to talk about electron configurations today and how the electrons are arranged. We need to know that electron configurations for ground state atoms is the number of electrons in each energy level. We will see that they fill 2, 8, 8, 8, 16, or 8. We will see that this number a lot of times here is actually 16, but it needs to go in this order, 2, 8, 8. If we vary from that order, we will see that that means something different. Okay, valence electrons. This is a topic that we will be using for the next several units. So we definitely need to know valence electrons are the electrons in the outermost shell. So that is the outside here. These outside electrons, these are what's called valence electrons. They get into the chemical bonding and the characteristics of each element. Okay, the last number in my electron configuration in the picture here at carbon is 2-4, so it has 4 valence electrons. Kernel electrons are all of the inside electrons. Now these guys don't do anything, but let's look at bromine, for example. So if I were to total up all of these non-valence electrons, all the ones in the inside here, all those electrons, those are what's called the kernel electrons. It's kind of trivial, to be honest with you. I'm going to make sure you know what it means, but we're not going to use it too much, I promise, and so it won't be that complicated. Isoelectronic is not one of my I words that I really care about as far as our 3 big I words, but it is it's our 4th I word. It's probably our least important one. What it means is same electronic configuration. So every ion will have the same electron configuration with some other base atom. If I take an ion or an atom and I turn it into an ion, my electron configuration changes. So guess what? That electron configuration is somewhere else as a base atom on the periodic table. That's what isoelectronic means. Okay, electron configuration for ions. Well, I start with the electron configuration of the base atom, then I add or remove electrons based on what kind of ion I formed, and I will always take those ions from the outermost valence shell, or add them to the outermost valence shell. That's the key, not the inside, the outside. Okay, electron configuration for excited state atoms. Basically, to sum it up, you don't hear it, you don't see this written, but anything that's not on the reference table is excited. Okay, so the normal 288 filling pattern, anything that deviates from that. Okay, so if I take an electron from this 8 shell and it jumps up here, he would now become 27, 6 or 2, right? This number should be 8 and before I start putting any electrons in this thing. It should go 2, 8, and then something else, and in this case it's 2, 7. That's how I know that it has been excited. So it deviates from this 2, 8, 8 filling order, okay? Now we get to play with it a little bit, so let's do that and solve these problems. I'm going to put in one piece, and we got to solve from there. So sodium. Sodium is Na. If we don't know it yet, we will learn sodium is Na. Looking at my periodic table, Na has an electron configuration of 2-8-1. It is, I see no charge up here, so therefore it is an atom. And 281 is what I read off the periodic table, so that is ground. With an N, Mr. Milks. That is ground state. Okay? Next one. 2873. I have 2, that's good. I have 8, that's good. This number should be 8 before I get any number here. And green didn't show up really good. This number should be 8 before I get any number here. So what happened was this was 8 and the electron jumped up there. Okay? So I know that this right off the bat is excited, and I was very excited about telling you that this atom is excited, so that's why we're doing this piece first. I wanted you to get a feel for that, but let's figure out who he is. I got 2 plus 8 is 10, and 7 plus 3 is 10, so this is 20 electrons. It is not an ion, so 20 electrons would equal 20 protons. So an element with 20 protons is calcium, Ca. And again, I don't see any charge, so it is an atom. We going too fast, Mr. Mokes? We going too fast? Should I slow down? Oh no, let's go. Keep moving, Mr. Mokes. We want to get this thing over with. All right, now I see this substance. I see Cl, that's chlorine. And here's the key to it right there, that -1. That -1 in the upper right-hand corner, we learned means it is an ion. and I put two I's. I didn't need to put two I's. I only need one I for ion, Mr. Milks. Let's get it right. Okay. Chlorine, let me look up its electron configuration. Looking at the periodic table, I see it as 287, 2-8-7, and it is ground because 287 is what I find on the periodic table. Ions are not excited. Ions are adding or subtracting. So I actually messed this up. It's not 287. I need to add one to this outer shell because it's a negative, so I added an electron. So it's actually 288. Mr. Milks, get your stuff together because I'm doing my notes in pen, and now I got to make it all messy. Sorry about that, but that's how we learn. Okay, 286. First number should be 2, check. Second number should be 8 before I get any in the third, check. So this is ground. This works out just how it's supposed to be. So we are good. Okay, let's add these up. 2 and 8 is 10, plus 6 more is 16. Who has, if I have 16 electrons, I should have 16 protons for a neutral atom. Periodic table tells me that is sulfur. I'm going to spell it. Sulfur, and that is element S. Okay, so we get good at this. It is, I don't see any charge, so it therefore is an atom. And we are good to go with that one. Moving on to the next piece. Na with a +1. So here's my special piece right there. I see a +1 in the upper right-hand corner. Tells me right away that I am an ion. I am in my ground state because ions don't have excited electrons. They've gained or lost one. So when I look up sodium's electron config, here, I'll show you. I'll do this one 2 times, okay? Let me look up sodium's electron config, which is 281. And then I have a +1 charge, so with practice, I know that I have lost an electron. Which electron do I lose? The outermost. So if I lose this electron, bye-bye, I am left with 2-8. This is the electron configuration for my sodium atom. A little while ago, we learned that isoelectric, right? So 2-8, I have an ion with 2-8. So 2-8, I look on the periodic table. Oh, neon has an electron configuration of 2-8. So the sodium +1 ion is isoelectronic with neon. Has the same electron configuration. You see what I'm saying? 267 is our next example. 267, 2 is good. This number should be 8 before I get anything here, and it's not 8. So there's a problem. That tells me I am excited. And I, of course, am very excited to tell you about this. And I am just an atom, though. I don't have more electrons than I'm supposed to. Let's add these bad boys up. 6 and 7 is 13, plus 2 is 15, and an atom with 15 protons, because protons and electrons equal for atoms, is phosphorus. Phosphorus, not bad, Mr. Milks, for somebody that doesn't know how to spell. That is element P. For those of us that need practice, knowing that phosphorus is P, we have one more example to do, and we are almost done with this video. Magnesium is Mg. Looking up Mg on my periodic table, I have an electron configuration of 282. I see no positive or negative charge up in the right-hand corner. That tells me I am an atom, and I am in my ground state because I got my electron configuration right off the periodic table. Thank you for bearing with my sloppy handwriting, but we good. And guess what? We're done with another notes. So you should have just completed page 25 in our packet. Make sure you hit done when you're done with the Google Classroom assignment. And we only have one page of practice, page number 26. Let's get going. If you haven't done it, we'll do it in class. And we done. Thanks for watching.